Short introduction about the company. So AVL, we have been founded in 1948, so quite some time ago. It's a private-owned company in Austria, which is leader for the powertrain development in the R&D. We are represented in more than 30 countries. I will show you the map. And quickly, what do? We offer engineering, testing solution, and simulation solution to develop the powertrain. So I just make it quick to support you, to help you to see where we can help the customer. And down you can see also all the different type of powertrain propulsion that are on the market. And I think from the previous presentation, you have seen how complex it could be and how diverse it could be in this powertrain. So as said, AVL has a very unique global network. We are very close to our customer. And particular, we have in AVL, we have AVL in Thailand, also in Bangkok. So we are very close to the customer. We speak the language of the customer, and we can directly answer the request and support also the customer with not only a sales office, but application and know-how sharing with our customer. But let's go through the content now. And the first thing, as I said, you have seen challenges from the previous presentation. And I would like to go a bit deeper in these challenges in the automotive product development. The reality is to develop such a great product like you have seen before, which are software-defined vehicle, over-the-air update, which have a lot of software now. We have came out of the pure thermodynamical development for combustion engine to a really software-defined vehicle where everything is embedded together with a high complexity. And the reality is that to develop this great system, now the team need to work in agile sprint. It cannot be in waterfall anymore. It cannot be in we call it the V cycle. It has to be really DevOps, CI/CD, it has to be very quick development because the demand for software and functional tests is increasing. The number of parameters, the number of labels, the number of all these parameters you have to change is increasing. And if you keep doing a lot of things manually, it is not possible. You cannot cover the gap. So as said before, also the presentation right before, the winner on the market will be the one who integrates smarter all these vehicles and all these components together. So traditional testing capacity is getting really low, so we need to go faster. And also you will see we can talk about artificial intelligence, AI, in the presentation. Here you can see a visual representation of what is happening. You can see there is a lot of teams. So when an OEM or a supplier of an OEM has to develop a product, so the final vehicle or component of the product, they need to work together with different teams. And you can see on the top, you can see testing team, software development team, simulation team, who are preparing work or working in the office. And down left, you can see that there is software in the loop factory, test factory. You have hardware in the loop also available to test. And you have the test beds where you test the component. So all these different equipment and all these different teams has to work together. And if you see on this representation, you see in the middle you have a lot of people working with these boxes, and actually it is all these teams try to work together, and the reality on the field is a lot of work is manual. A lot of file data are exchanged still manually or inefficiently, let's say. It is as it is because the system complexity is high, and what we try to do in AVL is to support the customer to reduce this complexity. So here, lack of cooperation and collaboration and high degree of complexity. This is what you see on the picture. And we have complexity in for the integration. We have a lot of environment to configure, a lot of assets to manage, a lot of labels, a lot of files, a lot of things to manage. The test coverage and the automation needs to be managed as well. It's very complex. The security of the testing also. So we talk also about cybersecurity. So it's coming more and more in the game, and also resources. We see that it needs a lot of resources to do the job in the actual stage at the OEM. Looking a bit more in detail, when we talk about powertrain development in the research and development in the R&D, these are the team we are trying to help. So we have the EE integration team, which is here, and their goal is to validate the seamless integration of multiple ECU. So you have seen from the presentation right before, there can be a lot of control units. Everything in the car now have a control unit, and they all come from different suppliers. They all have to connect together. So the challenge is to make everything working together. So the pain is to integrate. There is a lot of integration issues when they test. Another team that we try to support is a test automation engineer. There is a lot of them. There is a test bed automation engineer, there is a software in the loop automation engineer, there is a hardware in the loop. So they have a lot of systems to take care of, and their pain is that they have a lot of tests set up with a lot of tools and a lot of parameters to configure. So we need to support them. The E-drive validation engineer, so his goal is to validate the electrified powertrain system under realistic and edge cases condition. Okay, and his pain is that the e-motor tests are expensive and they are limited, so they cannot do everything always on a physical vehicle. Also, what is important is you do not want to finally do all this work in the final vehicle, in the final prototype, because this is extremely, extremely expensive. So you need really to do all this validation in an early phase. So you need to try to do it in software in the loop, in hardware in the loop, in a test bed, but then it's more complicated because you have not everything available, but it is cheaper. And finally, the SDV software engineer, so he wants to enable a continuous integration and development. He wants to be sure that during the development everything is flawless, that everything is going good, and he wants to be sure that in the future the over-the-air update, the OTA updates are really smooth. So it's very, very important. So where time gets lost, maybe more in detail in this whole environment. So first of all, when you need to test something, so a powertrain or a component of the powertrain, this is all what you have to do. So first you have prerequisite. You need to make sure that the test environment is prepared. You need to make sure that the test cases exist in the ALM, in the overlayer. You need to be sure that you have the latest software, the latest control unit software with the latest data available. And with this, you need to prepare the test. And I will go a little bit quicker, but you need to define the virtualization, you need to get the latest software version for everything, dataset, you need to create a test cases, so this is the blue part for the test job preparation. And finally, you need to execute. It's look nice, you press play and you go, but executing is also not so easy. You need to check if the test environment is ready. You need to pull all the artifacts from the different environments together. You need to flash the different control unit with the latest value, and finally you can execute the test. Is it finished? No, you need to upload the result in a server, because it's easy to get results, to put them somewhere on a USB stick, but actually how do you share it with your colleagues? OEMs have thousands of engineers working together. So having one result file and then sharing it with 1,000 people is not that easy. So this is a complexity as well. And finally, you need to do the post-processing. Where is the time loss? Creation of the models, it takes up to 6 days to put them on the hardware in the loop. We have from OEM, so some you heard already today, 60% of the whole process is only used to create test cases. Just to prepare a test, to create a test, 60% of the time is used there. Another OEM said that they have 75 engineers who are creating these test cases. It's quite some resources. And for the flashing, assuming that 30 minutes you need for a flash, so, and you do 1 flash per month, it's 6 hours per year, but if you do 1 flash per day, it's 8 days per year just to flash control units. It's a lot of time lost, and at the end, not all the tasks are automated, so you don't see it, but a lot of time is lost. So these are the challenges to develop and to integrate all these very premium system like you saw in the previous presentation. So the release cycle needs to speed up as well. The competition is very hard in the automotive industry today. So the winners will be the one who integrate well, but also the one who do it quick. So this is very important, the speed. So if we look today, I like to call it the plate of spaghetti. So you see that there is a lot of toolings and a lot of things between the engineer, the testing capabilities, the ALM system like this Jira software, or the repository for the control unit parameters. So the AVL Creta, for example, is very isolated task, very manual flashing and very fragmented tools. What we do in AVL is to support the customer to go from this phenomenon to a more collaborative ecosystem, trying to structure and automate all this testing. So we want to have this aligned process and tools to gain speed and obtain the full traceability behind. Here we have an example of a vehicle simulation, because in the presentation I want to show you a little bit more about simulation, about hardware in the loop, because to go quicker, one of the solutions is to do less thing in a physical environment, like a component test bed or a real prototype vehicle, to go more in simulation. To do more simulation, what you need to have is a simulated vehicle. So here, for example, you can see the different control unit. You had example before, but transmission control unit, vehicle control unit, e-axle control unit, and so on. So here there is even cabin controller. So there is also cabin control unit, because everywhere is control unit. You have the so-called plant model. So you have, for example, the driver. You need to model the driver. How will be driving the person in the vehicle? You need to model the thermal system. You need to model the simple cabin. And also, in that case, it's a BEV truck. Okay? So you need to model this one. And then you need to have some stimuli constraints from the environment. And you want to test different predefined cycle. It can be legislation cycle, or it can be cycle where you want to test a little bit beyond your system. And user functionality are also available, so it can be many of them. And when you have this, and you want to really simplify and automate the system, then there is different steps. In this presentation, we put 5 steps. The first one is a trigger. So to automate, the first thing you have to do, it's triggered by a daemon. So the user will start and press play, but before this, we'll give the latest software. So you can see software change. It will get the latest data set for the different control unit, and then it will start in the pipeline. So there will be a new software change, a new update, and then on demand, the user will trigger, I want to test now. But that's not all. He wants to test. Now we know what are the parameters, what the cycles, everything we want to test. Now he has to test. How do we go to test? Because to test on a seal, software in the loop, to test on a hill, hardware in the loop, or on a test bed for component or even chassis nano powertrain, you need to convert this requirement into a test case for this environment. And this is why in AVL you can see we highlighted a little bit the focus. So we have an AI translator which will then take from the requirement from the user and translate with large language model into the test case of the tool which is running the testing. So this we will do it, and this is interfaced directly to the OEM's ALM PLM. So this system which have all the requirement and parameters. It is AI driven and it is robust against different languages. So it's also localized. We have a lot of requests to have the local language of the country which is applied, because users don't always speak English or even German. It is seamless over any type of environment, and you can test within minutes. In the past, to create a test, it was taking 2-3 hours at least, so people were industrializing. Now with AI, you can do it very quickly. So new or change requirement reflects directly in the testing within minutes. This is what we bring. Then you need to automate. In that case, we took the hardware in the loop because this is the trend. Software in the loop, hardware in the loop are more used, as already mentioned. What you can see now is the manual workflow. How do you do a project on a hardware in the loop, which is one of the test environment? You first have a platform independent, so you need to have a gateway model. So you need to create the model which is connected to each control unit you want to address. So you need to go to the model I showed you before from the BEV truck, for example, and you need to adapt this one to the real control unit. This takes 1 to 2 days. It is not something which is light to do. Then you need to configure the project. So for each ECU topology, you need to configure your hardware in the loop to receive this model and this control unit. This takes 2 to 3 days. And finally, you need to interface all the models together because you don't always have one model. So you need to interface them together with I/O and so on. This is 1 to 2 days. And this is very manual, and this is today. In premium OEMs, this is how it is done today. So these numbers don't come from AVL, they come from our customer. And what we bring is tooling which help to automatically generate all these I/Os, automatically create the hill-specific configuration, and auto-link this for your hardware in the loop. And this is a 40% cost saving because you have 40% faster to do hardware in the loop project. So we have OEMs, we have customers with almost 200 hardware in the loop with a huge team doing this, and every time they do a project on one hardware in the loop, they use all these days. So imagine 40% saving there, okay? And then the next step, the step number 4, is we want the engineer to do it automatically. If we talk hardware in the loop, it's something which has a model. We don't want to be directly seated on the hardware in the loop. We want the user to be able to use it wherever he is. It can be that the hardware in the loop is sitting in Thailand, maybe, and actually a user from Japan is making it, or vice versa. So this is something that you can do if you have an automatization. So we have a tool which you can parameterize in the office, and then it will tell you which hardware in the loop on the planet from your office, from your team, is available from you. And then he will send this to the hardware in the loop and then make the test for you. So this is also a big tendency for larger OEM, larger supplier where there is a lot of hardware in the loop. And step 5, closing the loop. As we said, no matter where you test, in that case the hill, what you want to have is a full traceability. So you want, from after the test execution, which is on the top in blue, you want then to send all the result to the different tools which need to be informed. So you want to send again to the PLM system to say, I have done the test you wanted, and here is the result. It passed or it's failed. You want to send to the dataset version. This is the new dataset that we have created out of the test. These are the parameters which have been newly generated. And you want maybe to integrate into a platform which is communicative in your company. For example, Microsoft Teams, you want to send to the different users of the team, hey, this test was passed, this test is available there. If you click, you can see the result directly. So you want automatization, but you want also full traceability. So no data are lost, you can always find back, which is very, very important, because imagine you have launched a car, it is driving since 5 years, and then there is a new cybersecurity attack. You have to update the dataset. You have to make an update. How do? You need to find back which project was on this car. You need to find back where are the data, and you need to be able to rerun the project on a hardware in the loop or software in the loop. So it's also very important for the life cycle of the vehicle with the new regulation in place, as we have heard today. I would like to emphasize, because this is newly in our portfolio, the hardware in the loop. So we now, to support the customer, after 20 years of expertise on the hardware in the loop market with a lot of application, we have decided to launch a new product. So our own hardware in the loop, it is called AVL Nexus Hill, where we have all the different capabilities to do hardware in the loop with all the different format and state-of-the-art hardware in the loop technologies. So this has been released this year, which is all the format with very flexible I/Os, multi-domain. So AVL has a lot of expertise in the standard ICE, but also a lot of expertise in e-drive, battery, ADAS, e-integration, and so on. So this system is supporting there. And we have an open vendor agnostics. This means that this is very easy to integrate in already actual hardware in the loop portfolio, or to integrate into this CI/CD pipeline, because we have this automation framework, and it is a very cost-efficient and future-ready solution. So with this system, we can bring the Hill as a virtual platform that you can attack from anywhere in your company. You can also design, it's designed for all these various applications, as I mentioned before. It is integrated in this CI/CD framework, software-defined vehicle framework. It is proven methodology with the modeling. AVL is very known for the modeling as well. Not only creation of model, but integration of the model, which is done via service and application that we have. So as said also, we have a lot of application engineer and service all over the planet in our local affiliates. So with this, we can really offer services like turnkey solution. I'm almost at the end of the presentation, but I would like to emphasize again, so the hardware in the loop is very important, but when we automize everything, we have this orchestrator, we call it AVL DevOps Pilot, and you can see again, from the top, you have all this ALM, PLM system, so all this system where you have all the requirements. So there is tools from the market which are not from AVL. So Codebeamer, for example, you have Artifactory, like GitLab, GitHub, and so on there. So all these then are orchestrated by the tool. Okay, the challenge is really this orchestration, and then send to any type of test system in a CI/CD style. So to say, yeah. So all is already CI/CD ready, and you can see down how scattered as are our customer OEMs and supplier test environment again. So this is very important. The complexity is there because the system are complex now in the car, much more than before. And also to test it, there is a lot of tooling from different companies. And this is where this orchestration, this AVL DevOps Pilot, for example, is very important, because this is how you can automize. Yeah, it looks simple on a slide, but actually in the real life, there is a lot of challenges. So to conclude, here we have a common orchestration layer, so which support this heterogeneous test environment. We can help to reduce overhead and downtime. This is very important. By automation of the different procedures and workflows. Full traceability. So this is a key. To get the full traceability, you need to do the things that I mentioned just before. But full traceability is really a key. And we have seen from the presentation before as well, to develop all this system, you need to have this. And with all of this, we enable the calibration and the test engineer to work efficiently in an easy-to-use way with a lot of user interface which are very simplified. Thank you very much, and I forgot, but thank you for Tai to give me the opportunity also to talk today.